Mystical, eerie, sometimes even menacing.
Bogs are seen as dark places. They are often the setting for murder mysteries or spooky tales.
Humans have been decimating bogs for centuries, with perilous consequences.
We've absolutely turned the ecosystems from sinks of carbon to sources of carbon. And so that's going to really exacerbate potentially climate change.
The unique ecosystems store vast amounts of carbon, but their potential has been overlooked for quite some time.
Peatlands are like lungs of the world. We could say that these are webs of life.
And these webs of life are under threat. But new methods could save the world's peatlands, as well as our climate. Strips of green in rural Germany. Something is growing here that could help rescue bogs. Most of Germany's wetlands have been drained and are unrecognisable. And Greta Gaudig and Matthias Krebs want to show what's been lost and how to get it back.
That was quicker than I thought.
They regularly take samples with the probe.
Lower down, it looks good, but everything above where it's dry is lost. When a peat bog is drained, it begins to decompose. You can see that in the sample. In the upper layer, where it's so dark, there's lots of decomposition.
This decomposition worries the ecologist. Peat is made up of dead plants, which sunk into shallow, slightly acidic water. This oxygen-poor environment doesn't allow the debris to decompose, and the carbon stays put. But draining exposes the layers to oxygen, which starts decomposition and binds it to the element. It is then released as carbon dioxide.
Peatlands are like polymaths. They can do so much. Their biodiversity alone is very special, and they are major carbon sinks. That's why it's so important that we protect peatlands, and not just living ones, but also the ones we drained.
Greta Gaudig has been fighting for peatlands for 20 years. She focuses on former bogs, which she not only studies but also works to restore through re-wetting. But it can only work if the farmers who live off the land agree. Germany has around 1.8 million hectares of peatland, an area roughly the size of Saxony. 98% has already been drained, mostly to make way for agriculture. Draining is a climate disaster because it makes carbon sources out of ancient carbon sinks. Peatlands now contribute about 7% of Germany's CO2 emissions. By comparison, national air traffic contributes just 0.15%, almost 50 times less. Greta Gaudig wants to turn these climate killers back into climate saviours, together with local farmers. A difficult and muddy task. She and her team are researching how crops could be produced on wetlands for the Greifswald-Meyer Centre.
Did you find it, Kino?
Yes, 262.
They find sphagnum moss at this measuring station. Moss may seem underwhelming, but these starry green plants could help save the planet because they're incredibly useful for what she calls paludiculture.
That comes from palus, which is Latin for swamp or marsh, so agriculture on wet boglands or swamps.
Greta Gaudig studied biology and was intrigued by these mosses even as a student. Their usefulness was little known at the time. She's currently working on an instruction manual for paludiculture.
I don't want to do science that just ends up in a drawer. I want it to be used, and this is a whole new kind of agriculture.
A system that could revolutionise how we grow plants. Peat is now used everywhere, in soil for home gardening or potted plants, by professional garden centres and for commercial vegetable fields. But our hunger for peat is hurting our wetlands. She wants to replace the peat used in plant soil with bog moss. But growing moss first needs to become more efficient. The team is testing machines for maintaining moss fields. It's precise work because they only want to remove the upper layer and preserve the precious bog below. This sample is for the lab.
Oh, das ist echt schwer. Heavy.
This paludiculture system was born at the Greifswald Meyer Centre, which is where Greta Gaudig examines her favourite plant.
This is the
peat moss biomass. We want to dry it first and then weigh it so that we know how much a farmer could harvest.
Sphagnum mosses have enormous potential for use in plant soil.
Bog mosses benefit the climate twice. First, they can replace peat in horticulture, a renewable material replacing a fossil fuel. That's the first one. And secondly, peatlands would be re-wetted to cultivate the mosses, which would mean that the high emissions that currently come from drained peatlands would stop.
The lab tests go well, as do the first field trials. She's confident that they can develop a system for mass production. This is where the ecological economist Sabine Wichmann comes in. Her job at Germany's most important peatland research centre is to ensure that projects have a solid economic foundation.
New areas will be needed to grow bog moss, and we're talking about hundreds or thousands of hectares. We'll need to convince farmers and landowners, plus the investment costs are high.
Which is why the next hurdle for the researchers is finding buyers. Perhaps they can convince a garden centre. Further north, Finland has Europe's most extensive peatlands. They're home to rare animal and plant species. But these biotopes also died as they were strip mined for fuel or drained to make room for forest plantations. Tero Mustonen has been working to mitigate the damage. He's a climate scientist and activist, and as a globally respected scholar, he also contributed to the UN climate change report. He has an especially strong bond with one peatland in his native Finland.
It almost feels like Linnunsuo is kind of a person. You see some kind of a presence here. For example, this wood piece that I'm now looking at may potentially be 2,000–3,000 years old. I often want to think that peatlands are the memory of Finland.
Without Mustonen and his non-profit Snowchange, Linnunsuo wouldn't exist as it does today. It's one of around 80 areas across the country that have been successfully rewilded, and it's near the 46-year-old's home village, Selki.
Because it has taught us everything we have needed to learn in order to make this a national program. And from that we started to learn and test and innovate. How can you restore a large peatland system?
A huge project of 110 hectares. Peat has been harvested here as fuel for decades. The mining decimated the landscape and poisoned the rivers.
It was severely impacted by human decisions for economic gain and energy production that had disastrous results. There was a fish death event and, of course, these impacts to climate because they are active carbon sources even after the mining has stopped.
Tero Mustonen's home village also felt the effects, 10 kilometres downstream. Einari Martikainen is a fisherman and Mustonen's longtime friend.
Just use one piece of wood.
I'll add more later. Stop being so skeptical.
The 69-year-old could only watch as peat mining nearly destroyed the nature and his livelihood.
I saw fish lying dead along the shore or floating lifelessly in the water. It was terrible. I was in total shock.
Martikainen and the entire village fought back. They sued the energy company with the help of Tero Mustonen's environmental non-profit and won. The first time in Finnish history that locals successfully halted peat mining. Snowchange purchased Linnunsuo to be rewilded.
It is vital to listen and understand the best parts of what Einari and others are telling us, because they contain potentially one element which is missing: wisdom. What is the right thing to do? We have ample choices of different pathways of responding. But who is having the compass and map on the right choice?
Linnunsuo is a model for damaged peat areas worldwide. And the project has been carefully documented to ensure it stays that way.
In the afternoon, Paul can build a little dam across this wetland.
Yes, another one.
From timber.
Yes, and then have the two big dens.
Environmentalist Alicia Jaume-Buscal from Spain is measuring greenhouse gases emitted by the soil. Nature is slowly but surely reclaiming the area after decades of exploitation. The measurements show the fight has been worth it. The drained peatland emitted 400 tonnes of CO2 annually, but the restored ecosystem now pulls as much as 100 tonnes of CO2 a year from the atmosphere. Just a few kilometres away, the rewilding process includes killing nature. Thousands of pines and spruces need to be cut down to help return the wetland to health. That may seem counterproductive, but peatlands are actually far better at storing carbon than trees and can better help us reach our climate goals.
We say that we have 5 to 7 years to act to stop leaching from the soil-based emissions, and we are working on every part of that nationally important river system and its catchments to restore it back to health.
An excavator has to fill old drainage channels to re-wet the bog, a difficult task for a peatland that covers more than 100 hectares. But it's the only way for water to start collecting again. Mustonen develops a tailor-made plan for each wetland.
We have to be very carefully thinking, where are we putting the actions and, for example, how deep or big the dams should be to enable the right water level.
The painstaking work has now been converted into a unique system for restoring wetlands across Finland. Snowchange oversaw about 66 rewilding projects through 2023, financed through donations and investors. A demanding mission, but also highly rewarding. Mustonen is extremely happy about nature's return to Linnunsuo. Migratory birds that had long disappeared have returned, along with more than 200 other animal and plant species.
This place shows that with persistence, courage and scientific commitment, we can still have a chance. And that's the biggest message we can tell from Linnunsuo.
A message from Europe's far north to the world. Back in Germany, the researchers from Greifswald are in Hanover to find out how their bog moss has been faring as plant soil. Greta Gaudig and Sabine Wichmann are curious to hear the results. Taifa, reeds, moss. The research department at the Lower Saxony Chamber of Agriculture has put the scientists' recommendations to the test.
Potted tomato plants or balcony plants that grow in 100% paludiculture substrate. This is the first time I'm seeing that. It's new, really exciting, and very encouraging.
Whether geraniums or tomatoes, the results show plants love the peat-free soil. Research manager Michael Emil believes in the paludiculture substrates and says they're also suitable for commercial greenhouses.
This material is ideal and has great properties, but cost is a problem. Right now, it can't compete with peat economically. It's just too expensive to grow.
But the potential is huge. White peat is usually used in plant soils in Germany. Replacing it would require growing moss on around 40,000 hectares. Just re-wetting a small fraction, 2.2% of Germany's peatlands, could meet the demand. Greta Gaudig hopes farmers will also see the potential.
My vision is that many agree and use paludiculture moss substrates in horticulture, that many farmers say, yes, this is an alternative for me, that makes sense.
Peatlands can yield more than mosses. In Mecklenburg-Western Pomerania, scientists are researching another marsh plant. Typha or cattails are also thought to be promising. The plants are robust and highly versatile.
Here we are.
Water levels are regularly checked to determine when cattails are happiest.
58 centimeters.
58?
Okay.
In wet peatlands, typha grow even when there's a drought, and they can cope with heavy rain. The plants are sturdy and an ideal building material.
Here
you can see what people want for construction. Insulating materials. A structure with air gaps which insulates well and is very light. These walls can also be used to make load-bearing elements.
Some in the construction sector have already seen the potential of the robust plant.
This is blow-in insulation material. It can be used like cellulose flakes or wood fibre. You can still see the shape of the leaves. It has an airy structure. It's solid, has a high load-bearing capacity, and can insulate at the same time.
The researchers now need pioneers and policies that support them. And progress is already being made. The German government began supporting paludiculture in 2023, helping protect peatlands.
I'm convinced that this is a great opportunity to create synergies between peatland protection, sustainable agriculture, and the supply of renewable raw materials. And that's what we need to address climate change and create a livable future.
One new collaborator is just a few kilometres away. Harvest time in the re-wetted peatland. Farmer Henning Voigt grows more grass.
I'm checking to see if the bales soaked up water during the recent rain.
Voigt has been harvesting more grass from these fields every summer for 8 years. His father began the process, and now the 29-year-old is turning more and more to bog farming. The experts in Greifswald share some of the thanks.
This is what I can contribute to the climate, to help solve this problem, use resources more sustainably, and help our climate. And this is my chance to do something for this small area that I call home.
Heimat, was ich hier irgendwo auch als solches bezeichne, zu tun.
Bit by bit, the Voigts re-wetted 2/3 of their farmland. They decided to become paludiculture farmers at their own risk. They have yet to receive any special subsidies.
This wasn't subsidized, so we had to work economically from the very beginning. Combustion was the most feasible and quickest to implement. And as a result, my brother-in-law took the step to install this heating plant as a pilot project, a prototype.
Ludwig Bork burns around 4,000 bales of dried moorgrass each year in his biomass heating plant. The carbon footprint is negative because burning the grass doesn't emit more CO2 than it's stored while growing, and the re-wetted bog absorbs additional carbon.
The Greifswald Meyer Center was always very generous with its knowledge, which allowed us to make scientifically sound decisions. This would have been impossible without them. They helped us feel confident that this was feasible.
The entire town now benefits from the innovative family business. Their biomass heating plant supplies a school, several office buildings, and about 500 apartments with affordable heat, even amidst an energy crisis. In Malchin, restoring a peatland became a win-win situation for the climate, farmers, and the local population.
So what's the latest thing you guys have been
Researchers in the US are also looking at how important peatlands are for the climate. Biologist Natalie Griffiths and soil scientist Randy Kolker are using these glass towers to research what a global climate policy should look like. And to do this, the biologist and climate scientist are peering into the future.
And this is just an experiment to demonstrate that this is how it might look 50, 100, 150 years from now.
The Marcel Experimental Forest, a US government research station in northern Minnesota. The facility has an annual budget of about $5 million, making it one of the most expensive climate experiments in the world. Natalie Griffiths is overseeing a groundbreaking project on how plant debris in peatlands will decompose if the climate changes. Samples have been buried in bags.
So we want to get a better sense of what's going to happen to these ecosystems under future climates. They're very critical ecosystems for carbon. This carbon's been deposited over thousands of years, and so it's really important to understand what's going to happen under warming for these really high carbon ecosystems.
Kolker and Griffiths heat up the peat, simulating a different climate in each glass tower. How will the bog behave at 9 degrees of global warming? The bags provide crucial clues.
It's been in for 7 years. It's pretty decomposed. And we have a lot of other bags buried in this peat here.
The higher the temperature, the more the organic components in the peat decompose. And the more harmful CO2 gets released, a disaster for the climate.
Warming really increases the rate of decomposition in the peatland. And so we've absolutely turned the ecosystems from sinks of carbon to sources of carbon. And it's an additional source of carbon dioxide and methane in the atmosphere that's really not well accounted for in these global models that predict our future climate.
Their data helps develop and optimize scenarios to better assess the impacts of climate change.
Stay out here for another 3 years. back in the ground.
Randy Kolker helped establish the research station more than 10 years ago. The 58-year-old isn't just researching the future, he also wants to help shape it.
The biggest thing that we're learning is, that we can affect how these ecosystems behave now and into the future. And if we want to mitigate or limit the ability of our ecosystems like peatlands to influence climate change, we need to start thinking about doing some things now.
Their findings have raised the awareness of peatlands at the highest political levels. And they are feeding into the UN Intergovernmental Panel on Climate Change, or IPCC, reports.
We're very proud of the impact we're making, and unbeknownst to this community, 20 years ago, was really the critical importance of these ecosystems. And so peatlands we're relatively understudied, but our current research is going to impact and get to the decision makers at all levels of government. Start thinking about how to conserve these ecosystems.
The scientific evidence shows that peatland protection equals climate protection, and the potential is enormous. Although peatlands cover just 3% of the world's land area, they store twice as much carbon as the world's forests. They may look dangerous or mystical, but these unsung carbon sink champions could become the ultimate climate saviours.